Today we are going to talk about redox reactions. Redox reactions involves oxidation and reduction. In redox reaction, a substance must be oxidized while another substance must be reduced. Oxidation is the loss of electrons while reduction is the gaining of electrons. In an equation, the oxidizing agent is responsible in removing the electrons from another substance. Similarly, the reducing agent loses electrons, thereby causing a substance to be reduced. The reducing agent itself is oxidized.
Note that the tendency to be oxidized or to lose electrons may be related to ionization energy, which is the energy required by an atom to lose an electron. The lower the ionization energy, the greater will be the tendency for an atom to lose electrons and be oxidized. Now let's discuss about oxidation number. A reaction involves oxidation reaction if there is a transfer of electrons as a way of keeping track of electrons during reactions. The apparent change of an atom is determined according to some rules. The basic rule is that all electrons in a monoatomic ion are counted with the atom, but electrons shared in the formation of a covalent bond are counted with the more electronegative atom. The rules for assigning oxidation number are as follows.
Hi! The oxidation number of an atom or molecule of an uncombined element is 0. Examples are carbon, oxygen, and arsenic. The oxidation number of any monoatomic ion is equal to its ionic charge. For example, are these. The algebraic sum of the individual oxidation numbers of all the atoms in the formula of a neutral compound is 0. For example is sodium chloride and potassium permanganate. Bye-bye! Welcome! The algebraic sum of the individual oxidation numbers of all the atoms in the formula of a polyatomic ion is equal to the charge of the ion, like...
We will now learn on how to classify reactions as redox or non-redox. Using the concepts of changes in oxidation numbers, we can classify the reactions as redox or non-redox, then identify the oxidizing and reducing agents. This is our first example. As we can see, the reducing agent here is carbon monoxide and the oxidizing agent is lead oxide. Therefore, this is a redox reaction since there is a change to its oxidation number.
Meanwhile, on our next example, which is this, has no change in its oxidation number, therefore this is an example of a non-redox reaction.
And now to the last part of the lesson, which is on how to balance redox reactions. The law of conservation of mass is satisfied whenever a chemical reaction is balanced. In balancing redox equations, a special technique known as the ion-electron method must be followed. In this method, the reaction is divided into two half reactions.
An example for half reactions is this, which is, as you can see, an oxidation reaction because it loses its electrons. And another example is this, which is a reduction reaction because it gained electrons. The complete equation will be this.
To summarize it all, oxidation involves the loss of electrons, as reduction involves the gain of electrons. The substance oxidized is the reducing agent, and the substance reduced is the oxidizing agent. Oxidation number is assigned to keep track of electrons during reactions. Redox reaction occurs when there is a change in the oxidation number, and it is a non-redox reaction if there are no change.